So in the last video, we went over the mathematics of how to get the equation of the new line or new line segment. And it involved finding the negative reciprocal slope and then substituting in to find the vertical intercept so that we could come up with this equation. So how do we do this in code? That's what this video is going to be about. Now, Xcode is what I was looking for. So how do we do that in code? Well, finding the negative reciprocal slope involved flipping the fraction for the slope and making, if it was negative, making it positive. So if we look at how we've represented things in code right now, this is the line structure, and we're representing the slope as a straight up decimal, a double precision floating point variable. And it might be better if we could define the slope separately, keep track of its rise and its run. So what we're going to do is define a structure that represents slope. So we're going to say struct slope, and the components or properties of slope are its rise, which we'll represent using a double and make the rise be 1 to start, and we're going to represent the run as a double. So if we have a structure that defines slope, then what we can do is use that structure to define properties in the line structure. So instead of declaring the slope here as a double, what we can do is declare the slope as a value, a property of type slope. We can use the structure that we just created. And so we'll just say that we want to create the slope using that whatever rise and run we want. So by default, let's just make it be 1.0, 1.0. So we haven't done anything different. Other than that, we have changed the property type, data type of the property slope for the line structure from a double to be of type slope to use this new structure that we've created. So then how do we fix the code down here? It's saying that, hey, we can't convert a value of type double to expected argument type slope. So what that means is we have to declare a variable called slope of existing road and set that equal to the following. So we remembered that from the mathematics that we did, that the slope of that existing road as a fraction was -1/2. So if we're going to define this in code, what we need to say is that the rise is -1 and the slope is 2, right? What that's giving us is our rise of -1 right here and our run of 2, which is right here. So we're going to make that be -1 and 2. And then when we create the variable for the existing road, instead of passing in the decimal equivalent, we can just pass in that variable that we created, which is an instance of the structure slope. So we're creating the slope of the road first, and then we're creating the instance of the line structure named existing road using slope of existing road and its vertical intercept. So this doesn't change much. It's just changing how we're representing the information in the problem we're trying to solve. So why did I do this? Because it seems like it made things a bit more complicated. Well, what it lets us do is we can now begin implementing the code that's going to let us simulate the mathematics that we did here. We're going to more easily be able to find the negative reciprocal slope. So let's write a function for that. If you've got a simple problem to solve, you should write a short, discrete function that solves that problem. So here's what that function can look like. We can literally call it get slope of perpendicular line. And how are we going to do that? We need to get it from a given line. We need to know what line we're dealing with. And we're going to return from that the negative reciprocal slope. So the name of the function is get slope of perpendicular line. It's getting it from a given line. The data type of that parameter is line, and it's going to return a value of type slope. So we should always write documentation for a function when we do it. So we've written a function here. We're going to go to the editor, we're going to go to structure, and we're going to say add documentation. And so this function returns the slope of a line perpendicular to the provided line. Parameter given line is describing the line that we are starting from, and it returns the slope of the line that is perpendicular. So what does this code look like? Well, in symbolic math, we flipped the fraction. We literally took the 1 and put it on the bottom and put the 2 on the top. Flipped the fraction and then made it be the opposite sign. Negative goes to positive. So in our code, we can make that happen like this. We can say that we want to return an instance of the slope structure. And what should the rise be? Well, the rise should be the run of the given line. So we're going to say, take that given line, take its slope, and instead of passing back the rise, we're going to pass back the run. And for the run, we're going to take the given line, we're going to take its slope, and we're going to pass back its rise. So that's how you flip a fraction in code. In math, with symbolic algebra, we just literally flip the fraction. In code, we've just returned the run for the rise and the rise for the run. So we flipped the fraction in that way. The last thing we need to remember is that we have to make a negative slope become positive and vice versa. And the way we do that is just multiply either the run or the rise by -1. So we're going to do that here by multiplying this value by -1. And so now we can say, okay, get the perpendicular slope, the slope of the new road from the cabin to the existing road. And that's going to look like this. Let perpendicular slope equal get slope of perpendicular line. And would really love the autocomplete to kick in for me here. But yeah, from what line? From the existing road. And if we run this code, we're going to see that when this runs, it returns back an instance of the slope structure, and that instance has a slope that is the reciprocal of the existing road. So it was -1/2 for the existing road, and now the perpendicular slope for the new road from the cabin to the existing road is the reciprocal, and it's positive. In the next video, I'll continue with the code implementation of this symbolic algebra, but as you can see, I'm running low on batteries. So the next video will continue the code implementation of what we did over here in the algebra.